All right, day 8, experimental design. So an experiment is when a treatment is given to a group or groups. So an experiment is something you set up, and you're trying to see, does this item have an effect? To do that, you need a treatment group or groups, and you need a control group. Now, this is used to find cause and effect between two variables. Not just, a coincidence, but actually does something cause an effect somewhere else. Confounding. Confounding occurs when two variables are associated in such a way that their effects on a response variable cannot be distinguished from each other. It almost looks like confusing. It looks like confusing, and if you think about it, it's kind of that way. You really can't make a judgment call. It's too close together, so it's kind of confusing what the effect is. So it's called confounding. Now, the control group, not the treatment group, the control group, is the group used to provide a baseline for comparing the effects of the other treatment or treatments. Depending on the purpose of the experiment, the control group may be given an inactive treatment or an active treatment. So the inactive treatment would be like we talked about previously, the placebo. You take a sugar pill instead of actual medication. Okay, that's inactive. Or you could do some kind of other active treatment, but not the one that's being tested or experimented. So the placebo effect, and this does happen sometimes, especially when you talk about, different philosophies and different spiritualities. There are many beliefs around the world that, positive thought and prayer, there's healing in that, okay? And just kind of willing yourself better. Or like, you start to get a cold, you're like, I just cannot get sick right now, and then you kind of get over the cold, you will yourself. Is there or is there not? But the placebo effect does happen. It describes the fact that some subjects in experiments will respond favorably to any treatment, even an inactive one. So there's they're doing a test study on blood pressure medication, and I go in hoping to lower my blood pressure, and I'm in the placebo group. So all I'm taking, unbeknownst to me, it wouldn't be any good if I knew. So I'm in group A, which is getting a sugar pill, and that's all it is, just a capsule with sugar in it. I'm getting a sugar pill, and the other group is getting the actual medication being tested. I take this sugar pill, and at the end of the study, my blood pressure has dropped 10 points, or 15 points, or whatever. Just like in the experiment group. Okay? That's the placebo effect. Obviously, this sugar pill, there's nothing saying that sugar pills will reduce blood pressure. But still, my blood pressure went down. And this does happen in experiments. People will just get better. Or whatever the experiment is, they'll have the same, maybe not as much, but sometimes they will, effect as the people who are actually getting real medication. So the placebo, as we've said, is a treatment that has no active ingredients, but is otherwise like other treatments. So again, I'm taking a pill that looks just like the pill that they're taking. Physically, from the outside, it looks exactly the same. This capsule has actual medicine in it. Mine has sugar in it. Double blind. Okay? Anybody in here ever play spades? Oh, no. What is it? Spades? What? No, spades. You ever play spades? Okay. Sometimes you can do a bet where you and your partner both don't look at your cards and you just make a wager on what you're going to get. It's called a double blind. Because neither one of you actually looks at your cards, and you just say, we're going to get this many tricks out of this hand. Okay? That means because neither one of them knows what's in their cards. Well, in a double-blind experiment, neither the subject or the people who interact with them and measure the response know which group is which. So there's a theory, some people believe that, if I know group A is getting the placebo and group B is getting the medicine, I might accidentally influence them or kind of like without mean to subconsciously wink, wink, nod, nod, and let them know that they're in one group or the other. So a double-blind study says someone else knows which medicine is which. You administer it, you won't know till the end, they won't know till the end. And it's kind of a way to kind of keep security on the test. Single blind. In a single blind experiment, either the subjects don't know which treatment they're receiving, or the people who interact with them don't know. So sometimes I might know a placebo effect, has a placebo, but people evaluating me don't know. So it's kind of like a reverse trick kind of. All right. All right. Replication. Okay? To replicate something means to do it again. You see the word repeat in there. Replication is the repetition.
You skipped a page.
Did I skip a page?
Yeah, you skipped a page.
That one right there, right over here.
Okay, key elements of experimental design. Randomization. Okay, if something's random, there's no pattern to it. So, randomization is the process of randomly assigning subjects to different treatment groups. All right, so complete randomized design. If something's completely randomized, subjects are assigned to different treatment groups just through random selection. So like I put all your names in a computer, I assign you each a number, and then I run a random number generator like we've done in the calculator, and then this many go to this group, this many go to that group. Kind of common sense. So, randomized comparative experiment for new instant breakfast product. So this is a layout of this situation. So, first you have a random assignment. One group of 15 rats here, one group of 15 rats here. Treatment 1 is the new diet. Treatment 2 is the standard diet they've been having forever. Then afterwards, you compare the weight gain. All right? So in this situation, each group is an SRS, systematic random sample, of rats using the experiment selected using random digits. So again, assign everybody a number, and then just randomly pick. The key elements, you have randomization, you have the size of the groups are equal, you have the treatments received, and the response variable. So each one of these, wow, love technology. There we go, just do this again, and this again. There we go, whee! Okay, each one of those columns is a different element. We have the random assignment, the size, the treatment, and the response. Okay? Now, randomized block design. That is a different type of way of doing it. Divide the subjects with similar characteristics into blocks. Then within each block, randomly assign the subject to the treatment groups. So the groups are not randomly designed. There's a reason, there's a method to the madness. But once you have the groups, then they're randomly assigned to different treatments. So look at how this one looks a little bit different. So when you group them, men and women, obviously, if you had 100 people, it's not likely that you randomly got all the men in one group and all the women in the other group. That wouldn't make sense. That wouldn't happen. Okay? So obviously, we are choosing to put all the men in one group, all the women in another group. Okay? That's by design. At this point, there's 3 different groups of therapy, 1, 2, and 3. So random assignment of those 3 therapies. So the men get randomly assigned to 3 groups. The women get randomly assigned to 3 groups. Okay, so in this case, the blocks consist of male and female subjects. They're divided into 2 different blocks. And then the 3 types of cancer therapy are set up accordingly. All right. Almost seems like we've seen this before. Replication is repetition of an experiment using a large group of subjects. So to test the vaccine strain of influenza, 10,000 people are given the vaccine, and another 10,000 people are given a placebo. So they're just shot with saline, salt water. They don't know any difference. All right? Because of the sample size, 10,000 in each group, the effectiveness would most likely be observed. Okay? The more people you have, the better chance you have of getting some data out of it, good data out of it. All right. So this will be posted so this can be watched. I'm going to click this. Phone should be put away.
All odds, where we make statistics count fusions, search for patterns, or tease out relationships. But just where all that analyzed data comes from is our next topic. One method for producing data is called an observational study. Let's follow a team of marine scientists to the remote Line Island in the middle of the Pacific Ocean. Their expedition's goal was to learn more about how human populations affect coral reef ecosystems, and they conducted an observational study to do so.
Coral reefs are one of the most fragile ecosystems on the planet. Even though they've survived for millions of years, today they're suffering quite a bit from the rapid changes that are being caused by human activities.
The Northern Line Islands are an archipelago containing 4 atolls that are a perfect lab for this research team, because each island has a different history of human habitation. Starting in the north, Kingman Reef has never had a human population. Next comes Palmyra, home to a military base during World War II, but now basically empty again. Then, Tabuaran, with a growing population of 2,500 people. And finally, Christmas Island with a population of over 5,000.
About Tabuaran and Christmas, the people actively fish for food and dump their sewage raw into the ocean. So what the Line Islands affords us is the opportunity to look back in time from the inhabited islands where we see what reefs look like today with local human impacts, moving back to lower and lower human population densities to what reefs look like before human activities hit the region.
The research team recorded the size and quantity of predator fish at all 4 locations. They bottled up samples from each ecosystem to check for water quality and carefully photographed how much algae was living on each island's coral.
I was expecting to see some evidence of human disturbance on the reefs, but I would have to say I wasn't really expecting it to be as clear as it was. The fewer humans there were, the more live coral there was. The more reef-building organisms there were.
The fewer humans, the more big fish there were too. These Line Island studies help describe how reef conditions nosedive as human impacts increase. Scientists didn't try to influence reef health. The studies were purely observational. The advantage of an observational study is that you don't disturb whatever you're examining, in this case the underwater ecosystems. But observational studies can't prove anything about cause and effect. They don't tell you why you see what you see. For help figuring out causal relationships, researchers rely on experiments. Unlike an observational study, which doesn't interfere with what's already happening in a particular setting, an experiment actually manipulates its subjects in some way to see how they respond. Here's how one team designed an experiment to see how certain dietary supplements affected the pain of osteoarthritis, a degenerative joint disease.
Despite the fact that large numbers of patients were taking these dietary supplements, it really wasn't clear whether they were effective. Wouldn't make sense if the treatment was not effective to spend money on something that's not going to work. In addition to that, if it turns out that it does have the potential to cause harm, people should be aware of that possibility.
what we did as a study team was develop a way to assess the question, do the dietary supplements help osteoarthritis pain? And we did that by defining the population of patients that we wanted to study, i.e. patients with clinical osteoarthritis disease, in a way that would make the patients as homogeneous as we could. And then added an outcomes measure, whether or not pain is improving.
The doctor started recruiting osteoarthritis patients for a randomized comparative experiment. The explanatory variable, or factor, in this case would be the type of medication patients receive. The experimental treatments are the different levels or categories of the factor administered to subjects.
In an observational study, for example, you would just study patients who were, say, already taking each of the supplements and trying to do comparison. There's problems with that approach because the types of patients taking one type of supplement may be different from those taking another type.
In this study, treatment groups were assigned to receive glucosamine or chondroitin, or a combination of both. There was also an active control group. They got a prescription arthritis medication already on the market, and a control group received just a dummy pill, or placebo. That way, everyone took a pill every day, so any improvement that patients had, just due to being in a doctor's care, would be uniform across all the groups.
The experiment was a double-blind experiment, which means that neither the investigator nor the patient knew what agent or placebo they were being exposed to. I think that's important because just as patients want to do better, I think physicians want to help their patients. And so if the patient or the physician knows what they're taking, then that is an element of bias.
The response variable is how much the subjects reported their knee pain to decrease, if at all. When researchers calculated the mean reduction in pain after 6 months for each treatment group, it turned out they all had fairly similar outcomes. So the dietary supplements were no worse or better than the prescription medication, or even the placebo. The quest continues for additional effective treatments for osteoarthritis. This was a well-designed experiment. Researchers randomly assigned their subjects, the treatments included control groups, and the number of subjects was large. To see exactly how not to conduct an experiment, now we can visit the lab of Dr. Confound.
Well, hello there. I'm so glad you both decided to help me test this new mood-altering medication. I'll call you research subject number 7 and you number 8. Now, to begin the experiment, I'm going to ask you each to assess your mood. Very bad, bad, fair, good, or very good. All right. Number 7, you first. Very bad? Oh, even worse than very bad. Oh, that's a shame. I'm sorry to hear that. Okay, and you number 8? Very good. Okay, well, why don't you each take a seat? Ooh, I'm sorry, there's only one chair. Number 7, you're not feeling well. Why don't you take it? You don't mind standing for a while, are you number 8? Okay. Now, I'm going to give you each a pill and see how you feel in 1 hour. All right, number 7, here's your pill. There you go. Oh, number 8, yeah, let's see. Something, yeah. Here, something for you. All right, your time is up. How are you feeling, number 7? You're looking better. Nowhere to go but up, right? What's that? You said between bad and fair. Well, let's say fair, since you're definitely feeling better. And you number 8? You're feeling worse than you did before? You're feeling very bad now. So sorry to hear it. Well, thank you so much for stopping by, number 7 and number 8. I'm happy to say you're my final 2 subjects. I can't wait to publish these exciting new results. Helping mankind can be so rewarding.
Well, that example is a little extreme. But the point is that knowing what makes a bad experiment bad helps you appreciate a good design. Let's recap the qualities of a well-designed experiment, like the osteoarthritis study. The subjects were randomly assigned to the treatment groups taking supplements or placebo. The groups were as similar as chance could make them. equivalent groups were compared. All were treated exactly alike, except for what type of pill they received. Neither the researchers nor the subjects knew who received supplements or medication or placebo. And researchers had enough subjects to observe a reliable difference in the pain measurement of the groups, if it had occurred. Unfortunately, no group stood out with drastic reduction in knee pain, but that's an important result to know about, just as important as if one group had their knee pain completely evaporate. Science can be a long, ongoing process. For Against All Odds, I'm Party Savetti. Tune in next time.